Okay, welcome to today's lesson. So we're continuing our lesson on transformations that preserve congruence. And our TEAC for today is 8.10b. And our DOL is given 4 problems. I will be able to differentiate between transformations that preserve congruence and those that do not with at least 75% accuracy. So the vocabulary words are congruent angles. So congruent angles are angles that have equal measure or are identical. So congruent means equal or same. Similar figures. Similar figures are two or more figures that have the same shape but different sizes. So an example of that is a small circle and a big circle. Corresponding angles. Angles that are in the same position in similar figures. So if we look at the bottom over here, we have a picture of the corresponding angles A and X. So as you can see, they're in the same position. So these figures look congruent. They look about to be about the same size. But if I were to extend this a little bit just to make it a little bit of a bigger triangle, then A and X would be corresponding, which we know that corresponding angles are congruent, right? So if X is 50 degrees, we know that A would also be 50 degrees. Then congruent figures. So shapes that are the same shape, size, and have the same angles. Pre-image. Pre-image is the image or shape before a transformation, right? So that's the old or the original. Rotation. So rotation is one of our transformations. It's a type of transformation that takes each point in a figure and rotates either clockwise or counterclockwise at a certain number of degrees around a given point. The shape stays the same, but the position on the coordinate plane changes. So we know that it maintains congruence, but the orientation, which is another word for the position, changes. Okay, our next transformation is a reflection. So that's a type of transformation that flips a figure across a line of reflection that creates a mirror image of the shape. So each corresponding point is the same distance from the line of reflection. So, for example, I'm going to go ahead and draw a small coordinate plane. We have our x-axis and our y-axis. And let's say that we have this triangle right here, and then we have this triangle right here. I'm going to say this is A, B, C. So then this would be B prime, A prime, and C prime. So just looking at this, I know that our x-axis right here was that line of reflection. And we know that the corresponding points A and A prime are both equidistant or the same distance from this line of reflection. So let's say this is just 1 unit. So they're both 1 unit away from that line of reflection. The next transformation is translation. It's a type of transformation that slides the point in a figure the same distance in the same direction. So remember that in a translation, if we're sliding it across the coordinate plane, if we're moving across the x-axis, we're going either left or right. And if we're sliding it across the y-axis, we're going either up or down. Okay, the next, or lastly, I guess I should say, we have dilation, a type of transformation that resizes a figure, making the shape bigger or smaller. So at the bottom here, we have similar figures. So we have the two pentagons and the two hearts where they're the same shape but different sizes. Then we have congruent figures where even though the shapes have been rotated, the pentagons are the same, the basketballs are the same. We talked about corresponding angles. And then let's quickly go over corresponding sides. So JK is corresponding to RS because they're in the same position or in the same direction on the shape. I can also say that KJ is corresponding to SR. So it doesn't matter which direction we're going, as long as on both sides, we're talking about the same direction, right? So we can either go KJ, which is almost like up to down, or we could have gone the opposite direction and said JK and RS. And of course, this last photo is demonstrating what counterclockwise is, which is this direction, or clockwise, which is this direction. Okay, so we have an activity here, which is to demonstrate that the angles are congruent, the side lengths are congruent. And this is just to reiterate that in a reflection, rotation, and translation, the shape maintains congruence. So the shape, size, and angles are the same. In rotation and reflection, the orientation does change. In a rotation, if we remind ourselves, rotations can maintain the orientation only if it's a 360-degree rotation, which means it just ends up in the exact same position that it started off in. Okay, so this is a review of the visuals for the different types of transformations. As you can see, we have translations, which an easy word to remember that is slide. Reflection, an easy word to remember that is a flip. A rotation, an easy way to remember that is a turn. And then a dilation, which we have to just know is a resizing. Okay, so if we look at these algebraic expressions or the rules, all of them start off with x comma y, right? Because we know that all coordinates, the points are x comma y. So in a translation, if we know that it moves left, right, up, down, we know that it's affecting the x-axis and the y-axis. And in this case, when we have x plus 2, if it's moving 2 across the x-axis, that means that we know that it's actually moving to the right. And then if it's y plus 1, we know that it's moving across the y-axis. We know that it's moving up 1. So in a slide or in a translation, if you're adding or subtracting a number to the x and y, you know that you're sliding it or it's a translation. Then over here, if we look at this rule for reflection or for the flip, we have x comma y arrow, negative x comma y. So we can see that our x became negative. So in a reflection, either the x or the y switches signs. So if we assume that x and y are positive, then of course the x here would become negative, the y would stay positive. But let's say our x started as a negative. When it flips, it would become positive. In a rotation, there's different rules depending on the direction that we know. Clockwise, it rotates, as well as counterclockwise, as well as the angles that it rotates. So 0, 90, 180, 270, and 360. And so I'll go more into depth about the rules later on, but just know that an easy trick to remember that it's rotation is that the x and the y are gonna flip. So the y would come first, then x would come second. And that's true for a 90-degree rotation clockwise and a 90-degree rotation counterclockwise. And then with 180, it's special because both the x and y become negative. And then with 0 and 360 degrees, it just starts off at x comma y and ends off at x comma y. So one of the ways that I like to remember the rotation rules is, of course, first I flip the x and the y, the order of them, in the 90 degrees and 270 degrees. But then I also know that a soldier goes right, left, right, left. And so this is specifically the rule for the clockwise direction. And counterclockwise would actually be the opposite. So 360 would still be x comma y. 0 degrees would also be x comma y. But in this case, I'm going to change the color now. In this case, rotation counterclockwise is actually the same thing as a 90-degree clockwise rotation. So that would be y, negative x. 180 is still the same, negative x comma negative y. And then for our counterclockwise of 90 degrees, that is the same thing as clockwise of 270 degrees. So that's negative y comma x. So if you remember it one way, you can easily just do the opposite to find it the other way. So resizing, we have to remind ourselves that this number in front is called a scale factor, and we use k to represent the scale factor. If the scale factor is equal to 1, the shape stays the same. In this case, the scale factor is less than 1. It's the fraction 1/3, which is approximately 0.333 as a decimal. And so that means that the shape got smaller. If the scale factor is greater than 1, then the shape gets bigger. Okay, so we're going to go on to our first we do. In our first we do, we have which of the following transformations maintains congruence. So again, we have to remind ourselves that maintaining congruence means that it stays the same shape, size, and angle. Okay, so most of our options, A, B, C, and D, you can see, well, A through C are all dilation. And we know that dilation does not maintain congruence. It's the only transformation that does not, because that's when the size gets changed, right? It either gets bigger or smaller. So our only correct answer is going to be D, reflection. Then for our next we do, which of the following does not preserve congruence? Now we have these algebraic rules. So we know that dilation does not preserve congruence, but we have to remind ourselves which one is dilation from the rules, right? So we have x comma y to negative x comma y. So if I remember correctly, since the x is in the same position, but it's negative, we know that this one is a reflection. Okay, then for B, we have x comma y to negative x comma negative y. Yes, the x is negative and x stayed in the same position, but because both the x and the y are negative, I know that this is the rotation of 180 degrees. Then for C, we have x comma y to 0.2x comma 0.2y. Anytime we're multiplying or anytime we have a number in front of the x and the y, that is called a scale factor. And the scale factor means that this is dilation. So we found our answer. Our answer is going to be C, but I'm going to go ahead and identify what type of transformation D is. D is x comma y to x minus 2, y minus 4. Anytime we're adding or subtracting to the x and the y, we know that is a translation. And the rest of the problems are you do as well as independent practice. So thank you so much for following along in today's lesson.